All right, here's what we're doing this week. We are evaluating and solving quadratics. So two things are going on here. When we say that we're going to evaluate, that word evaluate means to find the value. When we're talking about functions and quadratics, if we're given, this is the most basic quadratic that we have, y equals x squared. If I said evaluate for x equals 2, I'm saying, give me the y value when x equals 2. What you would do is take that 2 and plug it in for x and square it, and that would give you 4. And you would say, okay, when x equals 2, y equals 4. Finding the value is this step right here. The value is 4 when x is 2. We're going to evaluate today two different ways. One is number 1 here, using a function, an algebraic form. And the second way is down here, using a graph. Both ways, you're still finding the y value when you're given the x value. It's just written or displayed in different forms. So let's talk about number 1 first. Now, the example I gave you at top said y equals, right here. But this one doesn't have a y. It has f parentheses x. Remember, that's our function notation. It's just another way of writing y. It's saying that I have this function that I'm going to call f, that's its name, and it's based on the variable x. That's what that notation means. So I have this function, f of x equals x squared plus 4x plus 5, and it's asking me to evaluate for f of negative 2. Well, let's look at that notation for a second. This right here was just f of x, where x is just the variable. But this right here is f of negative 2. What's changed? The x has been replaced by negative 2. This is just another way of saying that x equals negative 2. Go figure out what the y value is. So we do the same thing that we did in the little baby example I gave you at the top. We just plug negative 2 in everywhere we see an x. So here's what that would look like. So instead of f of x, I now have f of negative 2. Specifically, that's what I'm trying to find. And that means everywhere I see an x, like here and here, I plug in negative 2. You have to be careful, though, with your order of operations and using parentheses around the negative 2. So when I plug it in for that first x with the x squared, I'm going to put parentheses around it to show that all of negative 2 is squared. And then I have plus 4 times negative 2, and then plus the 5. Now here you have to be careful that you're following your PEMDAS order of operations. Simplify inside parentheses first, that's the P. But when you look inside your parentheses, all there is negative 2. There's no more work to do there. So really, there's no P step. So we did that. E stands for exponents. This is the place where there's an exponent. Think about what negative 2 parentheses squared means. It means negative 2 times itself. What sign does that give you? It gives you positive, right? So that's a positive 4. The biggest mistake here is to make it a negative 4 because you squared the 2 only. Be sure you're including the negative. So now we do m for multiplication. That's the 4 times the negative 2. That's a negative 8. And then the plus 5. And now you can do addition or subtraction from left to right. 4 minus 8 is negative 4. And then plus the 5 is 1. So your answer is 1. And sometimes people like to write the function notation still and say f of negative 2 is 1. You can write it in either form. But it's basically saying when x is -2, y is 1. So I just wrote a whole bunch of extra stuff. Here's your answer. That's the answer right there. And just as some extra information, if you were to write this as an ordered pair, when x is -2, y is 1, just like that. So that's the algebraic way to evaluate a function. Let's look at doing it with a graph, graphically. So given the function graphed below, so you see there's no like f of x equals x squared plus 5x equals 6 or -6 or anything like that. Instead of an equation, we're given a picture. It says determine the value of f of 3. So this picture represents the function f, and this notation is saying, okay, x equals 3. What does y equal when x is 3? So what we have to do is, now here's where x equals 3 on the x-axis, right here. But that's not what I'm asking. That's not what I want. We're talking about the values on this graph right here. This is my function. I need to know where's the point on that graph when x is 3. So here's how I do that. I just trace up to the graph. I find this point right here. That's the point on the graph where x equals 3. I want to know what's the y value equal to there. So I just go to the left until I hit it on the y-axis. And right there, what does y equal? It equals 5. So that's my answer. No math involved. Okay. So that's how to evaluate functions to find the value of y when you're given an x, either by plugging it in and simplifying or by reading it off the graph. So that's the evaluating part of our notes. The second part of the notes is solving quadratics. This means we will have to be doing some factoring. Oh my gosh, this pen. Oh my goodness. Okay. Ah, dang it. It's supposed to say factoring. So the way we're going to be factoring is a few ways. Well, actually, I should back up a little bit. I say factoring, which we are going to do a lot of factoring. But even before that, we're going to review the quadratic formula. So we're going to solve a quadratic one time with the quadratic formula, and then later we'll do factoring. So here's the quadratic formula. We are going to use it to solve this equation. Now, before you can do that, let's just see what this problem says. This problem right here isn't actually the solving part. It just says use the quadratic formula to plug in the a, b, and c. And in order to figure out what those values are, we have to put the equation in standard form first. Right now, it's got an 8 on the right-hand side. Standard form is when everything is set equal to 0. So to get it that way, I'm going to start by just subtracting 8 to both sides. And that gives me 5x squared plus x minus 8 equals 0. Okay, and that is standard form. This is the general standard form, ax squared plus bx plus c equals 0. So once it's in this form, we can figure out what a, b, and c are. It's the coefficients. So you can tell that a is 5, b is the number in front of x. I don't see a number in front of x, so I know that it's 1. And c is your constant at the end, it's -8. So I'm going to take those values and plug them in here to the quadratic formula. And here's how that will look. X equals negative, this negative right here comes from the formula. B is 1. Okay, plus or minus, I'm just going left to right in the numerator. The square root. Inside I have b squared. So that's 1 squared minus 4. That's part of the formula. A is 5. I'm going to put that in parentheses. And B is negative 8. Be careful with that negative, that you put it in parentheses and you know that it's there. All of this is over 2 times A, which is 5. So that's the setup. That's all number 3 was asking us to do, was set up the problem. Number 4 is asking us to go further and actually solve it. So you really need to do your order of operations here, but you want to start under the radical first. So your first step is PEMDAS under the radical. All right, so so I'm looking right here. Let me highlight this for you so you see where I am. So here's what's under the radical. The first thing you're looking for is for your P letter. Are there any parentheses that can be simplified? No, right? There are 3 sets of parentheses, but inside each of those is just one number. There's nothing else you can do there, so we can move on to the next step. E stands for exponents. Find the exponent under the radical. It's the 1 squared, right? Okay, so I'm going to write that down. 1 squared means 1 times 1, which is just 1. And then the next step is multiplying. There's definitely multiplying. There's the negative 4 times 5 times negative 8 right here. And we're just going to do that left to right. Negative 4 times 5 is negative 20. And then times the negative 8 is positive 160. So I've got 1 plus 160. Notice how there's no more negatives under there, okay? So it's still inside the square root. It still has negative 1 plus or minus outside, and it's still all over 2 times 5, which we can now do as 10. So I'm gonna add what's inside the radical. And from here, you can just go to your calculator. What I want you to notice, though, is there's going to be 2 answers, right? Because this is a quadratic. That means there's 2 solutions. There's a plus version of this answer, negative 1 plus the square root of 160. Which, by the way, if you go to your calculator and you do the square root of 160, you'll get approximately 12.7. And that's over 10. And then there's a negative version, negative 1 minus the square root of 160, which is 12.7 over 10. And then staying with your calculator, you're going to find each of those. You're going to do the numerator first, the negative 1 plus 12.7, which is 11.7 over 10, which is approximately 1.17. And then for the second answer, you're going to do the numerator first. Negative 1 minus 12.7 is negative 13.7. Divided by 10 is approximately negative 1.37. And that is your 2 answers for quadratic formula. And the reason why quadratic formula is something that's helpful is because you'll notice the answers are decimals, right? That means you could not have factored that problem and gotten an answer. Notice whenever we're factoring, we're getting whole numbers or easy fractions. You wouldn't have been able to factor in this case, like to do the cross method or something. And so that's what quadratic formula is good for, when you need a solution in certain cases. So that was quadratic formula, check. And number 5, we're going to talk about 2 different methods that you can solve this kind of a problem. So we're switching away from quadratic formula. What I want you to notice here is that I have two things, first of all, being subtracted. And those two things are special. They are both perfect squares. The first one is x times itself, and the second one is 4 times itself, right? That's what 16 is. It's 4 squared. So I have x squared, and I basically have 4 squared. And if you remember, that's called difference of two squares. So, and we're going to do two different methods here. Method A is called difference of squares. Or difference of two squares, or whatever, something like that. We'll hear it different ways. And we've talked about this before. What you do there is you take the square root of each one, and you make a minus version and a plus version. With those two values. Now it's equal to 0, right, from the original thing. And we know from here that to solve, we just set those two factors equal to 0 and solve those two baby equations. X equals 4 and x equals negative 4. Okay, so that's one way, difference of two squares. Another way method B is to do square roots on both sides. Just use square roots. It's technically called square root property. We're just going to shorthand it like this and call it square roots. So the way that looks is you go back to the original problem. And you're going to isolate the squared term, meaning get it by itself. That looks like this. You add 16 to both sides. X squared equals 16. You square root. And you kind of get x equals 4, but remember when you're square rooting something, there's two versions. Plus version, because plus 4 times plus 4 is positive 16, and a negative version, because negative 4 times negative 4 is positive 16. So either way, you get positive 4 and negative 4. You can do difference of squares or square roots. So real quickly, before we start on the back of your note sheet, what we've just done is this. We evaluated or found the value of quadratics. In number 1, we did it algebraically by plugging in an x value, doing the math to get the y value. In number 2, we had a picture. So we found where x equals 3 on the graph and figured out what y matches it. That was my answer there. So that was evaluating quadratics. Then we solved some. We solved in 3 and 4, we solved for x by using quadratic formula. And in number 5, we solved for x by doing difference of squares and a square rooting method. On the second page of your notes, we will be solving quadratics, but first setting them up for word problems. So, in fact, I've just decided I'm going to make a second video for the word problems. So this first video will be just the front side of your notes, reviewing methods, and then I'll make a second video that's just the word problems.